test for divisibility. What these do is they test a number to see if it's divisible by 2, 5, or 3. That's the test we're going to have. So instead of actually physically dividing the number, you can just look at it and say, oh, 2 is a factor of it, or 2 divides that number. So like here. So if a non-zero number can be divided by another number, so that the remainder is 0, then we say the first number is divisible by the second number. So example, 2 is a factor of 6, and 2 will divide 6. So 6 is divisible by 2. 6 is divisible by 3. 6 is divisible by 6. It's the numbers that will divide them, and you can say 6 is divisible by this. So these are tests for divisibility. So to see if 2 divides a number, we want to see if that number is divisible by 2. So let's just look at it this way. If you have 2, you have multiples of 2, you get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. These are all evens, right? It's one way of looking at it. But if you look at the last digit, it's 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. 2, 4. Anytime that 2 goes into a number, then the last number has to be a multiple of 2, the last digit. So if you look at 330, 330 is divisible by 2 because it has 0. Same with 332, 334, 336, 338, etc. So if you had 457, this is not divisible by 2. But if you had 458, well, the 8 is divisible by 2, so 458 is divisible by 2. That's it. You just have to look at the last digit. If it's even, then 2 divides it. And then what we also get is for 4. If you want to see if a number is divisible by 4, because it's a multiple of 2, then you just look at the last 2 digits right here. So if you had 12,524, if you look at just the last 2 digits, the 24, if 4 goes into 24, then 4 goes into the entire number. Okay? So since 4 goes into 24, 12,524 is divisible by 4. And the main reason is this. If you take away that 24, you're left with 2 zeros. Those 2 zeros represent 100, right? It's 12,500. And 100 is made up of 10 and 10. Or let's just make it even simpler. 100 is made up of 4 and 25. So we already know that 4 will go into that number. So you just have to see does 4 go into 24. That's the whole point. So if 4 goes into the last 2 digits, 4 divides the number. That's it. Alright, and then for 8, it's the same idea. 8 is 160, because 1,000 would be 8 times 125. So we already know that 8 goes into it. So again, you just have to look and see at the last number. If 8 divides the last 3 digits, 8 divides the entire number. Now these two are not as important as 2. 2 is the one we want to really focus on, but you can kind of see the pattern. So if you want to do 16, which is the next number, it's 2, 4, 8, 16, 32. If you want to do 16, you would look at the last 4 digits. And if you want to do 32, you look at the last 5 digits. That's it. You don't have to look at the whole number. But I mean, with those large numbers, it's not going to be that big of a deal, because you already know 2 and 4 and 8. They'll take care of what we need to have taken care of. Alright, so let's go down to the bottom here. These are our numbers. So we're going to be testing 234, 721, and then 100,002, 5,210. We're going to test and see if they're divisible by 2, by 3, by 5, and by 7. So we've already done the 2, and it just has to be the last digit. So is the last digit even? Yes. So I want you to put a yes. 721, that's a no. 100,002, yes. And 5,210, yes. And that's it. That's all we're doing. We're just testing it for divisibility. We'll see uses of these later. Alright, so for 5, if you look at 5, these are the numbers that are multiples of 5. So these are the numbers that are divisible by 5. And it's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. What's the last digit? 5 or 0. That's it. So if the last digit is a 5 or a 0, 5 divides the number. Okay, so I want you to try that for these now. Do the 5. Look at the numbers, and I want you to put yeses or no. So hit pause, fill them in yes and no, and then I'll unpause it with the answers. So we pause. Okay, and there's what we should have. Last digit is 4, so no. Last digit's 1, 5 does not divide that. 2, 5 does not divide that, and 0, ooh, there we go. 5 is a factor of that. 5 will divide that number, so 5,210 is divisible by 5. Alright, 3 is my favorite, and that's right above here. If 3 divides the sum of a number's digits, then 3 divides the number. I know it seems a little confusing. Sum means add, so if you take the digits of that number and you add them up, if it creates a number that is a multiple of 3, or a number that 3 will divide, then 3 divides that entire number. It's pretty amazing, right? So like 327, 3 plus 2 plus 7 is 12. Well, 3 will divide 12, therefore 3 divides 327. Don't believe me? Let's try it. Here's a calculator. What is 327 divided by 3? 109. Works every time. Pick any number. 1, 1, 1. Those are all divisible. Those are all add up to 1 plus 1 plus 1 is. So if you had 1 plus 1 plus 1, that's 111. That's 3. So does 3 divide 111? Let's find out. 111 divided by 3. 37. Anything you pick. Let's try 2, 6, 5. What does that add up to? 8 plus 5 is 13. So we need another 2. That'll give us 15. So 2 plus 6 is 8, plus 7 is 15. Divide by 3. Bam. Watch. Just 1, 1, 1, 1, 1, 1, 1, 1, 5. 1, 2, 3, 4, 5, 6, 7, 8. Plus 5 is 13. Let's get some more up there. 14, 15, 16, 17, 18. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Plus 5 is 18. Divided by 3. Bam. No decimals. It goes in perfectly every time. Here's the reason why. If you had 327, right? And what it means is 3 hundreds, 2 tens, and a 7. That's expanded notation for 327. Well, if you take that and break it down even more, 100 would be 99 plus 1. 10 would be 9 plus 1. So what we get is this. You get 3 times 99, distributive property, plus 3. 2 times 9, plus 2, plus 7. And then if we rearrange it, you get 3 times 99, plus 2 times 9, plus 3, plus 2, plus 7. And that was what we were doing. We were adding those up to see if they make a number that is a multiple of 3. And if you look at it, 99, well, that's a multiple of 3, so we know 3 divides that one. 9, 3 divides that one. So all you have to do is check this one. It's going to work every time, because if you had 1,000, it'd be 999, divisible by 3, plus 1. So it's just the digits themselves that you have to check. That's it. So try it again now for 258, if you want. I'm not going to go over it, though. You just need to know the rule. You don't have to know why. I just have to tell you. So what I want you to do, though, is use that rule. So take the numbers, add them up, add up the digits, and then tell me if it is divisible by 3. So hit pause and try it. And these are your answers. So the first one, 2 plus 3 plus 4 is 9. So yes, 3 divides 9. 7 plus 2 plus 1 is 10. No, 3 does not divide that, so 3 will not divide 7. 21. 1 plus 2 is 3, so yes. And then 5 plus 2 plus 1 is 8, so it's a no. It just gives you a quick thing. So we're going to be reducing fractions. If you're going to be doing prime factorization, if you're going to be factoring a number, it'll tell you whether or not 3 will divide that number. So it gives us a start. It allows us to break a number down into smaller parts. It's nice. And it can give you a quicker route. So like if we have 234, we know that 3 goes into it. So you can take out your calculator. 234 divided by 3 is 78. See? Told you it would go into it nicely. 78. And they go, oh, there's a 2 on there. 2 and, because it's even. So we go 2 and, well, what's 78 divided by 2? 39. Well, what's 3 plus 9? That's 12. So 3 goes into that. And that's 13. 13 is prime, and that's where everything comes back. So we'd get 2 times 3 times 3 times 13. And this is prime factorization, which we're going to be doing in a little bit. You may have already know how to do it. But it's a way to break the number down into its prime factors. But 3, 2, they're very, very nice. Same with 5. It gives us numbers that we know. How do you know with 7? You don't. There's a nice tricky one online. If you want to look it up, go for it. But it's just basically you do 234 divided by 7. So that's a no. 721 divided by 7. Yes. 103. What am I putting the number there for? I don't know. It's supposed to be a yes symbol. Alright. 7 into 1, and then there's 1, 2, 3, 4. 2 divided by 7. That's a no. Yes. I thought it was a no. And then 5 to 10 divided by 7. That's a no. There's going to be a reason why we're checking 2, 3, 5, and 7. And when we get to prime factorization and finding out if a number is prime or composite, you'll see why I picked those numbers. But the tests you want to know are for 2, 3, and 5. Those are very important.